All right, so this is the last part of 3.2. So this is talking about continuous compound interest. So continuous compound interest is all about, it's the same idea as compound interest, but now we are continuously earning interest. Now, this does not mean that you are earning an infinite amount of interest. So if you remember, when we were talking about exponential functions, the number e is an irrational number, and it's 2.78, and it continues on forever. So it can only reach a certain level. All right, so when you say continuous, it doesn't mean an infinite continuous. It's continuous up to a certain amount, okay? So the variables all mean the same. A is my ending amount. P is my beginning amount. R is my interest rate. Again, rate has to be a decimal. And T is time in years. Now, this should look very familiar to you because you've already seen this before. When we were working with exponential and log functions, I introduced the continuous compound formula. So it should just be kind of a review for you on this one. So if I'm asking for find the time, well, let's do a straight one first, just to get your skills warmed up. So let's say I have a single payment of $1,000. My rate is 8%, and I'm going to leave it alone for 15 years. Okay, so again, this principle with continuous compound interest, this is a one-time investment. All right, I'm not continually adding more money to it. It's one time, and I'm letting it sit and earn interest. So here we go. We're looking for our amount. Our principal or beginning amount is 1,000. We will always have the natural number e. My rate is 0.08. And my time is 15. So with the continuous compound interest, if you have all the information, you can just plug it in. So it's going to be 1,000 times e raised to the 0.08 times 15. Make sure that is all in parentheses. That 0.08 times 15 should be in parentheses because that tells the calculator that that is an exponent for e. So my amount after 15 years is $3,320.12. Okay, so not bad for letting something just sit for 15 years. You haven't lifted a finger, and you have earned $2,320 in interest. All right, so that is when you just do a straight number. So now let's see if we can find the rate and or the time. So let's say we are looking for the rate. We're going to go 20 years, and we're going to see what the rate is. At the end of 20 years, I have let's say it's a $12,000 amount. All right, so I'm ending with 12,000. I started with 1,000. I left it in for 20 years. What's the rate of interest? So you could look at this as I want to buy a car in 20 years. How can I get my $1,000 to grow to $12,000? So here we go. We have our $12,000. We have our $1,000 that we started with. E raised to the R times 20. So now we have an exponent that is unknown. So we have to isolate the e, which means I'm going to divide by 1,000. So I get 12 equals e raised to the 20r. I just flip-flopped it. Now e is isolated. What is the inverse function of e? Well, it's ln. So when I ln and e, remember that cancels. So I have ln of 12 equals 20r. Remember, it drops down. Now I have a straight equation. To get r by itself, I'm going to divide both sides by 20, and I get r equals So you go ln of 12, close it, equals divided by 20. So 0.124. So my rate is 12.4%. So remember, going from a decimal to a percent, you take your decimal point, you move it twice, and that is your percent. So 12.4%, that's not bad. That is doable. You have to have it in a higher risk investment, but it is doable. So that is how you're going to find rate. Now we're going to flip it around and we're going to find time. So let's say, start with a different amount. Let's say I have $3,000 that I want to invest. I want to buy something. I don't know how long it's going to take, but I know I need to get my $3,000 to grow to $10,000. I also know my rate is 8.75%. Okay, pretty good yield, pretty good amount, interest rate. I want to know how long will it take me. Okay, so we start with our 10,000 is our ending amount. Our beginning amount is 3,000. E is our natural number, raised to the 0.0875 times the time. Okay, so just like when we were looking for rate, now we're looking for time. Time is our exponent, variable in the exponent. So we have to isolate the E. Isolate the E. 10,000 divided by 3,000 is 3.33. This looks familiar. Equals E raised to the 0.0875 times T. E is now isolated, which means I can ln both sides. That cancels the E. So I have ln 3.3333 equals 0.0875 times T. And now I can divide both sides by 0.0875. So ln 3.333, close my parentheses, divided by 0.0875, and I get 13.76 is my time. So what does that mean? It means it takes 13 3/4 years for my money to grow from 3,000 to 10,000 at an 8.75% rate. Okay?